Hey guys, Astrophotography here. So I kind of wanted to do a video today on signal to noise ratio and why I think is important for astrophotography when it comes to exposures and all that type of stuff. So I kind of want to give a brief rundown on what exposure time is and how it kind of plays out, especially when it comes to nebula imaging, galaxy imaging, and deep sky objects in general. So as you see, I have four photos, all with different exposure settings, and for the time for each integration is different in each of these. I kind of wanted to show a difference between a 300 second, 120 second, 180 second, and as well as a 60-second exposure settings. And the difference between a 300 seconds, which is a 5-minute exposure, the longer exposure time allows basically just more light to reach the camera sensor, as well as resulting in a better signal to noise ratio. The advantages of a longer exposure is to allow it to collect more light from faint objects, revealing finer details pretty much, reduce the noise, and the increased signal helps suppress the noise, resulting in smoother images and color saturation. Bright stars and nebula benefit from longer exposure, enhancing their colors. But with longer exposures on nebula that are rich in a certain element like oxygen, hydrogen alpha, you typically don't want a 300-second exposure because you have the ability to blow out the core of whatever you're trying to image. For galaxies, it's more appropriate for deep sky objects like galaxies and all that type of stuff, and as well as less impact from tracking errors too. Another thing that I've noticed that you have to consider when it comes to 300-second exposures is saturation. Why I said earlier, you sometimes can blow out the core of nebula if you go for too long of an exposure versus a deep sky object like Messier 63. And Messier 63 was one of the best ones I've taken so far of the galaxy itself, and I kind of wanted to use it as this demonstration. I planned a Messier 63 almost exclusively to avoid any plane satellites or just satellites in general, because satellites are starting to become an increasing problem now that Starlinks and other companies are starting to launch what Starlink is trying to do and accomplish. Even though they're 5-minute subs, it basically uses less frames, so you can stack like five and you can get a really good signal to noise ratio compared to, say, if you stacked 50, 120, 180-second frames. So it's really good, but also at the same time you're also going to be impacting your saturation, and that's another thing you have to take into account is not overblowing the core and doing more color correction time. Another good example is 180 seconds pretty much, and this image here that I have, which is the Messier 94, is a 180-second image for a total of 35 to 40 frames stacked each. So it's got a moderate signal. It also helps with planes, satellites, and all that stuff as well too. So, and it also has less impact from tracking issues, and it's also got reduced saturation because from tracking issues you could get double star trailing or just star trailing in general if you have any sort of guiding problems from your mounts and all that. That's basically all I mean when it comes to tracking issues. Another thing to consider is that it would take an extremely more integrated time, as well as since you're at a lower exposure, you would have to basically go for to basically make the signal to noise ratio better, you would require more integration time, which is the unfortunate downside of a 180-second image from a 300-second image. Another prime example is if you are dealing with satellites, less integration time or less exposure time will actually minimize the impacts versus a 300-second image. Yeah, you got M63, M94, which is a 180-second. M106 was a 120-second image. for about a total of 20 to 30 frames. And compared to M94 with it being 180 and M63 being 300 seconds, you can see noticeable noise in this image specifically. And the reason for this image, for the noise in this image, is because we didn't have a lot of frames. We were only using about 20 to 30 frames, and it just impacted more because of the signal to noise ratio, and the signal to noise would have been qualified as bad signal to noise ratio, pretty much is what I'm trying to say. The only noticeable difference from Messier 63 is that it has noticeable detail compared to what Messier 106 and Messier 94. So this is kind of just a prime example of what to do and what to look out for when it comes to exposure settings. The other one I wanted to show you, which was a 60-second image of the Cat's Paw Nebula in Scorpius. And now keep in mind, this was post-processed in Luminar Neo to remove noise, although you can still see there is noise and considerable star trailing. And the reason for the star trailing is I come to find out that we were actually having guiding problems at night on the Siding Spring, Australia Observatory. And when we were taking this image, I noticed that a little bit of the core was blown out, specifically the middle nebula of the part of the nebula itself was more overexposed due to the fact that the hydrogen alpha emission, which was at 60 seconds, had a lot more saturation, and it wasn't typically good, so we had to do a lot more color correcting work to get it to not be oversaturated. There was a lot of problems wrong with this photo, and even though we were able to minimize it, it's still a good photo overall. So the difference between all these photos, they all have one thing in common: integration time. And integration time is essential in astrophotography. It takes up a lot of time to basically create these images, and specifically Messier 63 and versus Cat's Paw Nebula and all these other objects. So this is basically kind of like a basic guide to exposures. What I've noticed from doing astrophotography is that there is a sweet spot. And for me, that sweet spot would be typically between 300 seconds and 180-second exposures. As well as for nebula photography, it would be about 60 seconds to either 30-second exposure images too. However, if you're working with fainter objects like in the narrowband region, you could typically go higher, but you would result in more star trailing. And that's the only thing that really sucks, is you have to account for tracking issues with your mount and all that stuff too. So I wanted to also let you know that I have started a Discord channel specifically for this YouTube channel. And if you would like to join, it is going to be in the description below. I hope to see all your astro photos and everything that you've been working on so far. And I hope you found this video useful. And until then, I will see you guys and stay curious until next time.